Okay, you all welcome to Workshop Technology subject. Today we are going to discuss about the screw thread cutting on lathe machine. Okay, one of the main operations. In this lecture, we are going to discuss about what are the calculations related to this screw thread cutting operations. That means basically we are going to discuss how to select the gear train to connect the spindle rotation and the lead screw rotation. Okay. Yeah, I think you all have seen the screw and screw threads, the internal threads and external threads. The various type of threads profiles are there. The various type of threads are there. Fine thread, coarse thread, extra fine threads, the V-shaped thread, square threads, different type of thread profiles, and also the different type of thread pitch values are there. Then these mostly these screws are used as the temporary joining method. Okay, the screw and nut and bolts, if we take the nut and bolts, these are used as a temporary joining methods. Then knowledge about this thread cutting is very important when talking about the lathe machine. First we are going to discuss how to select the gear train to cut a certain pitch of the screw. Depending on the pitch value we have to cut, we have to select the gear train first. Okay, with the older type lathe machine, that means lathe machine does not have thread cutting gearbox. With that lathe machines, the gear bank is coming. Gear bank is starting from the 20 teeth to 120 teeth in a 5 steps teeth interval. The gear bank is coming. Then according to the pitch we want to cut, we have to select suitable gears from the gear bank, and we have to set the gear train to get the required gear ratio. But in nowadays the lathe machine, most of the lathe machine equipped with the auto gearbox for thread cutting purpose. So then, this lecture is focusing how the gear train basically developed using by connecting the different gear wheels. Okay, that means in the thread cutting process, spindle rotation have to synchronize with the spindle movement. So what is the relationship? Per one revolution of the spindle, the spindle have to move the pitch value in thread cutting process. This is the relationship. This relationship is developed by connecting spindle shaft and the lead screw shaft through the gear train. Compound gear train and the simple gear trains are used to connect this connection. In this lecture, we are going to discuss in detail how to design this gear train to cut a certain pitch of a thread. Okay, let's continue to the theory of this lecture. Okay, in this lecture, we are going to discuss about the screw thread cutting. Lathe machine. Screw thread cutting on a lathe machine. Okay, theoretically any type of thread can generate using the lathe machine. Okay, so I think you all have seen the screw thread, no? Screw thread. So what are screw threads? Okay, screw thread in a nut and bolts. I think you all have seen the nut and bolts at least. Then this screw thread having the helical profile, helical path, and different profiles. Maybe the V-shaped profile, or square profile, or round shape profiles. Okay, this kind of various profiles, thread having the various profiles. Okay, depending on the application, but they all having the helical path. What is the helical path? If you take the Okay, the helical path. See the screw, the helical path. Okay, okay. That means this profile, that means V shape, square shape, or round shape, or whatever any other, is the path of this profile is the helical path. Helical path. Okay. Then these screws mostly used to convert the actually the screw and these screws are used as the temporary fastening method. They mostly in nut and bolts you can see is a temporary fastening method to assemble the component. This nut and bolts are used. It's a temporary fastening method, and also it also used to transmit the to convert the rotary motion to a linear motion also. Okay, to convert the rotary motion to a linear motion also. Then this helical path, the distance in between the two similar points is called the pitch. Distance in between the two similar points of the screw is called the pitch value. Pitch value. Okay. Then when talking about this screw, you should know the multi-star threads. So what is the this is for the single star thread. What is the multi-star thread? Multi-star threads. The knowledge about this multi-star thread also very important. Yes, I will explain this one. The multi-star thread means there's a multiple start points. Multiple start points. That means if we take a certain screw, it having the multiple threads. Multiple threads. Okay, let's take this is a screw. So one thread. Let's take the 2-star thread for example. 2-star thread. Then this is the one thread profile. With the one thread. Okay, one thread. Then again at the same time it having the another thread. You can see two thread profiles, two threads are there, the single screw, but there's a two threads. That means if we take the elevation from this direction, we will look at from this direction, we can represent this the starting point of the two threads. So one is starting from here, this thread, and this is the second start point. Okay, this is the first start point with the second start point. Consider two start, that's why it's called the two-star thread. You can see the two threads are parallelly on this same screw. This is called the two-star thread. Same time there's a multiple two or more, maybe 3 or 4 threads are running parallelly each other. These are called the multi-star thread. When talking about the multi-star thread, the pitch value is same. The distance in between the two similar points on the screw is called the pitch. This is called the pitch. Okay, these 2 points may on different thread. Okay, this is one thread, this is another thread, but the two similar point on the screw, this distance in between the two similar point is called the pitch. Okay, then distance in between the two similar point on the same screw Distance in between the two similar points on the same screw is called lead. This length is called the lead. Okay, this length is called the lead. Then the lead is equal m times into pitch. Pitch means the number of starts. Number of starts. Okay, if you take a 3-star thread, it having the 3 threads on a screw. On this screw, take a 3-star thread. Okay, one is starting from here. Okay, the another one here. Okay, we take another one. Like this. If you look from this direction, we can see the 3 start points, 1, 2 and the 3, the 120 degree apart. 120 degree, this angle is equal 120 degree apart. 3 start points. Okay, simultaneously driven on the screw parallelly each other. Okay, parallelly each other. Then what is the advantage of this multi-star thread? Why not only the single star thread? What is the advantage in multi-star thread? What is the purpose of this multi-star thread? Okay, I will explain that one also. Then what happened? Let's take this nut is connected to a this bolt is connected to a nut. Okay, this bolt is connected to a nut. Per one revolution, what is the extension in here? Is it pitch or lead? The extension is equal to lead, not the pitch. Okay, that means 2p. Okay, at the same time, if it is connected to a nut, okay, this is let's take it is fixed. Then per one revolution of this bolt, what is the extension in here? That is equal to 3 pitch. Okay, that is equal to the lead. Okay, that is the advantage. In the multi-star thread. Per revolution, the extension is more compared to the single star thread. What happened if you take the single star thread? Per one revolution, the extension is equal to p, only p. If you take the single star thread, okay, the extension is equal to pitch value. Then what is the difference between these three? You can see if we increase the number of stars, we can get the more extension per less revolutions. The situation where we need more extension with less revolutions, we are using the multi-star thread. For example, the screw press machines uses screw press machines uses this technique the multi-star thread use, because to get the higher extension for lesser revolutions, revolutions, the multi-star threads are used. Okay, screw press machine having the nut here, then the screw multi-star thread screw, and this is the one half of the mold. Okay, other half of the mold. Okay, place on a then this is the rotary hand wheel, either rotary hand wheel. Then this is a multi-star thread. Multi-star thread, because with the lesser revolutions we can move fastly this mold half in a downward direction more quickly with the lesser revolutions of the screw. Then the same load can take as the single star thread, because it having the multiple thread profile. The strength is same with the single star thread. Okay, strength of the thread same with the single star thread, but the advantage is per lesser revolutions we can get the higher movement extension. In the mostly this is the one of the very good example, the use of the multi-star thread, and also the various the rotary to linear drivers also use the multi-star thread to the situation we need the higher extension, higher linear movement with the lesser number of revolutions. Okay, this knowledge about this multi-star thread also very important. The lathe machine also can cut the multi-star thread. Later we are in after few lectures we are going to discuss the multi-star thread cutting operation also. Okay, then let's move to the first we are going to discuss the single star thread cutting process. Okay, first we are going to discuss how to cut the single star thread, using the lathe machine. The single star thread having only one single thread. Okay, one only single thread, the uniform pitch value thread. Let's see how to cut this kind of thread using the lathe machine. Okay, in thread cutting operation, I'll draw the schematic diagram of the structure. Let's take, this is the lathe chuck, the work holding device. Okay, this is the spindle. I think you already know this component, spindle. Lathe chuck. Okay, then I will draw the workpiece. Mounted on the lathe machine. Then this is the center, the front end from the tailstock. Then this is the workpiece. Then I'll do the cutting tool also. Depending on the thread we are cutting, the nose cutting tool nose radius have to adjust. The 55 for the inches thread, 60 degree for the ISO threads. Okay, later we can discuss these things. Cutting tool. Then this cutting tool is connected to the tool post. Tool post is connected to the sandal. Okay, sandal. Then in a thread cutting operations, the relative path of this cutting tool tip is, what is the relative path of the cutting tool tip? This is rotating in this direction. Then we have to produce a relative path, elliptical relative path. Tool have to move relatively this path. Okay, in thread cutting process, the relative movement of the tool is, relative movement of the cutting tool tip with respect to the workpiece should be this elliptical path. According to the pitch we are cutting, it should have this pitch value. Okay, see the pitch value. That means how to do that one? While rotating the spindle, the tool have to move in this direction. Okay, tool have to move in this direction. In this movement, for one revolution, what should be the tool travel? It should equal to the pitch value to keep this elliptical path uniform pitch value. Each revolution of the spindle, each revolution of the workpiece rotation, what should be the tool travel, that is equal to the pitch value. Okay, then how to, you can see this rotary motion and also the linear movement of the cutting tool should be interconnected. That means these two motions should be synchronized. This synchronization is done using the gear wheels and also using the lead screw. Okay, this cutting tool is connected to the sandal. Then this sandal is connected to the half nut. This is the half nut. That means this half nut means is the one half of the nut actually. Then this half nut we can engage and disengage to the, this is the half nut. I will draw that in that way. Actually it's a half of a nut. Then I will draw the lead screw also. Lead screw. Okay. This is the illustrative diagram. Lead screw having the square thread profile, square thread profile. Okay, and this is connecting to the, this is connecting to the, okay, this is the lead screw. Okay. Okay. Then this half nut, this is called half nut. This half nut can engage and disengage. Where situation we want to cut the thread, we can engage with the lead screw. This is called the lead screw. Okay, this is called the lead screw. Then when we are thread cutting process, we can engage. Then if we, in other situation we can disengage, engage and disengage. There is a lever to engage and disengage this process. Okay, then we have here we have the, by rotating this lead screw, we can move the cutting tool in this direction. We can produce the linear movement for the while rotating the lead screw. Then now our problem is reduced to, synchronization of two rotary motion. What are the two rotary motions? Spindle rotation and also the lead screw rotation. Now our problem is simplified to synchronization of two rotary motions. How to synchronize the two rotary motion to a required ratio? So what actually what is this thing? Let's take this lead screw having the pitch of P dash Okay, per one revolution of the leaf screw, what is the tool travel? That is equal to P dash. What is the required tool travel? That is equal to pitch to be cut. That means this is the thread we are going to generate. This is the pitch value we want. Okay, to get the P value, in order to get the P distance per one revolution of the spindle, we have to rotate this leaf screw. Okay, this leaf screw. So how to do that? By connecting these two shafts through the set of gear trains, set of gear wheels. Okay, I will draw these gear wheels also. And these are the gear wheels. The spindle gear wheel. In simply understand this gear connection, but in real situation, it will be different. Okay, you can see this is connected through the gear trains. You can see the three gear wheels are connected. While rotating in this direction, this one is rotating in this direction, then this one is rotating in this direction, same direction with the spindle rotation. What is the connection we need? Per one revolution, this one should be travel pitch value of the screw to be cut. Okay, this is the schematic setup in a thread cutting operation on the lathe machine. These set of gear wheel we have to arrange, okay, according to the pitch to be cut. The various type of pitch we have to cut on the lathe machine: 3 mm, 4 mm, 1.5 mm, 0.8 mm. Various type of threads are there. Okay, depending on the application, the various type of threads are there. According to the pitch value, we have to decide what is the ratio, what are the gear wheels we have to take for this operation, because this is constant. For a lathe machine, the lead screw we can't change. It's the architecture of the lathe machine is a fix. Okay, this is fixed. So that only thing we can change is this gears we can change to get the different speed, different rotation for spindle shaft and the leaf screw shaft. Okay. Okay, then I'll explain this one also in further to get this ratio. Okay. Let's take in a thread cutting operation. Let's take this shaft is produce the N S. I will take the spindle S for the spindle. NS revolutions. Okay, NS revolutions for the workpiece. During this NS revolution, what should be the tool travel? For NS revolution, what should be the tool travel? That is equal to NS into pitch value, no? NS into pitch value. For one revolution, it should be travel the pitch value, no? For NS revolutions, NS into P. NS into P. Then let's take this is the lead screw rotation which is connected. Let's take NL. This one should equal to NL into P dash. Okay, NL into P dash, because this is the distance we want to travel the cutting tool. This is should achieve by rotating the lead screw. Then this is the fixed value. So what should be the rotation we need for the lead screw is equal NS divided by P into P dash. Okay, NS NL the lead screw turns is equal to NS into P divided by P dash. Okay, P dash. I think you all clear with this how to obtain this equation, no? Okay, then from this equation we can derive another important equation. The P mean pitch to be cut. Pitch to be cut. The P dash, pitch of the lead screw, pitch of the lead screw is equal to, this is equal to here NL divided by NS is equal P divided by P dash lead screw turns divided by spindle turns. Okay, here we have developed a very important equation. What is the speed ratio? Speed lead screw turns divided by the spindle turns is equal to pitch to be cut divided by the pitch of the lead screw. This is how we are obtaining this equation. Okay. Now we have come to a certain important step. Pitch to be cut is known, pitch of the lead screw is known. Then we have to relate these two rotary motions through the gear train. To connect this connection is done using the simple gear train and the compound gear train is used. Let's I think you will having the basic knowledge about the gear train, no? The gear trains. So I will just I will give you the basic idea about this gear train because you should have a knowledge to understand this how to connect this spindle and lead screw through the gear train. You should have a knowledge about the gear train. So that I will give the basic knowledge about the gear train first. Okay. Then let's next we can come to this equation to further develop. Okay. First let's move to understand the gear trains. Okay. Okay. Gear trains. The gear train assembly of two or more gears in machine is called the gear train. Assembly of two or more gears. Assembly of two or more gears in machine. Here the machine mean in here the gear machine mean the gears are in contact called the machine. The word we are using the machine. The assembly of two or more gears in machine is called gear train. Okay, gear train. Then this there's a four type of gear trains. The four type of gear trains. The first type, simple gear train. Simple gear train. Second type, compound gear train. Third type, riveted gear train. The fourth type, epicyclic gear train. These are the four type of gear train available. Okay, but in lathe operations, to develop the gear train to connect the spindle rotation and the lead screw rotation, we are using only these two. simple gear trains and the compound gear trains, we are not going to use the reverted or epicyclic gear train for this to design this gear train. So we are going to discuss in detail about this simple gear train and the compound gear train. You will learn about these two gear train in your machine subject on second year, third year level. Okay. So what is my simple gear train? First one, simple gear train. First one, simple gear train. What is the simple gear train? Simple gear train is the simplest form of the gear train. Each shaft having the gear mounted on it. Each shaft having the gear mounted on it. Okay. Okay, I will draw the definition also. In simple gear trains, each shaft carries only one gear. Only one gear. Each shaft carries only one gear. Okay, let's take this is the example. You can see the one gear wheel, another gear wheel, another gear wheel. All three these gear wheels are connected to one single shaft. If you look from this plan view, you can see something like this. This is the first gear wheel, then the second gear wheel. Okay. Then next one, third gear wheel. Okay. Is a gear wheel. Okay. Then how to calculate the gear ratios? Let's take this is having the T1 teeth. Let's take this is having the T3 teeth. Then if this is rotating with N1 revolutions, let's take this is having the T2 teeth. Let's take this one having the N2 teeth. Sorry, T2. Then let's take this is the speed of N2. Let's take this is if this is rotating in this direction, what is the direction of the rotation of this wheel? That is in opposite direction, anti-clockwise direction. If this is in anti-clockwise direction, this side should be clockwise direction. Then these two GV sign rotation in same direction. So what is the how to calculate the N3? Okay. I think I'm assuming you don't have the knowledge about this gear calculation, so that I will explain that one also in separately. Okay, how to calculate the speed ratio if we given this T1 and T2 and T3, these teeth values are given in a machine gear train, then how to calculate the speed ratio. Okay, let's see how to do that one. I think I am assuming you don't have this knowledge. Okay, I'm going to do that in separate note. Okay, then how to calculate the gear ratios and speed ratios for machine gears. Okay, let's take the simplest example. Okay, first of all, I'm going to explain how to calculate the speed ratio in between the two machine gears. Okay. Forget about the gear wheels. Let's take the friction rollers. Okay, let's take this kind of friction rollers. This is the roller. Okay, let's take another roller is contacting with this larger diameter roller. These two rollers are in contact. This is rotating. This is also rotating without slip. These two without slip. This is the friction rollers, cylindrical surface. These rollers having the cylindrical surface. Those are rotating without slipping. Let's take this diameter as D. Let's take this diameter as D. Let's take this diameter as simple D. Okay. If this is rotating with N1 speed, what is the speed of the second gear wheel? Then how to calculate that one? How to calculate that one? Okay. This is rotating with N1 speed. Think in this way. What is the circumferential length it travel? Circumferential length in travel. For one revolution, what is the circumferential length? 5d. For N1 revolutions, 5d N1. That circumferential length should equal to the circumferential length of this smaller wheel also. Smaller roller also. So that 5d into, okay, because there's no slip, circumferential length should equal to the both the wheels because there's no slip. If there's a slip, we can't equate this one. We are assuming there's no slip. So then we can design the equation from this. D by simple D is equal N2 divided by N1. You can see the diameter ratio is equal to the inverse of speed ratio. Okay. In gear wheels, if you take a gear wheels, I think you all have seen the gear wheel, no? Gear profile. To mesh the gear profile, that means the involute gears are common in among the gear wheels. The involute gear profile having this kind of shapes. Okay, if you take one single teeth on the gear wheel, I will draw the gear wheel also. Let me draw the gear wheel and explain. Okay, let's take the gear wheel. Okay, to illustrate this process, I will simply draw this triangular shape gear profile. Actually, it's a involute profile. To illustrate this one, I will draw this simply in this way. Okay, this is the gear wheel. Okay, then this is the machine gear wheel. Okay, machine gear wheel. Let's take, we are going to mesh these two gear wheels. Okay, then if you take let's take this if you take this length, let's take it is x. Okay, that means this gear profile length. Okay, length belongs to one teeth. Is x. Okay, length belong to one teeth is x. Then how many possible teeth on this gear wheel? Let's take, if this is having the T1 teeth, how many possible teeth? T1 is equal, what is the total circumferential length? 5D D, simple D. Forget about the pitch circle diameter. Let's take this one. The 5D divided by x. 5D divided by x. Okay, you can see. Okay, this is the number of teeth on the first J wheel. If you take the second J wheel, to mesh these two J wheels, this gear profile should be same. That means this teeth also should have same profile, and this length also equal for this J wheel also. Otherwise, these two J wheels are not properly meshed. If one is very small, what happen if the one is very small? If one is very small, like this, we can't mesh these two J wheels. No, we can't connect these two J wheels. That means gear profile should be same. Gear profile should be same to mesh each other. In that way, this teeth also should have same x value. So that for this J wheel, what is the T2 teeth? T2 teeth is equal 5 simple D divided by x. Okay, 5 simple D. This one we can write in this way. This one we can write in this way. T1 is equal K into D. This one is equal simple K, constant. K is a constant into D. Then you can see, you can substitute this D is equal T1 divided by K. Simple D is equal T2 divided by K. So I am going to substitute these values in this equation A. Then we are getting in this equation A, I am going to substitute these two found values. Okay. The T1 divided by K, T2 divided by K is equal N2 divided by N1. Okay. So finally we are having the equation T1 divided by T2 is equal N2 divided by N1. Okay. I think you all more clear with this equation, obtaining this equation. Here you can see the speed ratio is equal to the inverse of the ratio of the gear teeth on the gear wheel. Okay. Keep remember, to mesh the two gear wheels properly, gear profile should be same. Gear profile should be same mean this length should be same. Otherwise, these two gear wheels are not properly meshed. Okay. In that way, we can develop this equation. According to the diameter, it having a certain number of teeth. According to this diameter also, it having a certain number of teeth. This teeth is proportional to the diameter. Number of teeth on the J wheel is proportional to the diameter. This is the speed ratio for the machine J wheels. Okay, I think you all clear how to obtain this one. Okay, then I tell this one also. The gear ratio. Gear ratio is defining in this way. Gear ratio is equal number of teeth on driven gear number of teeth on the driven gear divided by number of teeth on driver gear. This is the gear ratio defining for the machine gear wheels, two gear wheels. Here the what is the driver. Driver mean driving gear wheel. The power is transmitted. For example, driver, if this is the driver, this is driven. This is driven because of this driver. Then the power is transmitted from driver to driven. Power is transmitted from driver to driven. This is the driver wheel, this is the driven wheel. This is driven because of the driver. The power is transmitted from driver to driven. Then this is how gear ratio is defined. I think you all got the basic idea of this speed ratio in between the two machine JVs. Let's move to our previous topic. We are discussing about the simple gear train. Simple gear train. Simple gear train. Okay. Then simple gear train. Here this is the simple gear train. Simple gear train means gear train each shaft carries only one gear wheel. You can see this only for each shaft it having the separate gear wheel. So then how to calculate if this is rotating? If this is rotating with N1 revolutions, it having the T1 and T2. Here it is N2. Here it is N3. How to calculate the N3 output? This is the output. Let's take this is the input. Let's take this output. Okay, this is input. This is output. Then how to calculate the output speed? How to calculate the output speed? What is the method? Okay. You can do in this way. Keep remember this method. Keep remember this method. Okay, this is the way we have to do. Keep remember this method. Here, this is having the T1 teeth and it is rotating N1 speed. For N1 revolutions, how many teeth contacting with this gear wheel? How many teeth are in contact with the second gear wheel when it rotates N1 revolutions? That is equal to T1 N1. Okay, that means one circumference. In a circumference there is a T1 teeth. For N1 revolutions it produces T1 N1 contact with the second gear wheel. Okay, for the second gear wheel T1 N1 contact. Okay, T1 N1 contact for the second gear wheel. In a circumference it having the T2 teeth. So how many revolutions? T2, that is equal to N2. Okay, it is equal to N2. Okay. Then if this is rotating with N2 speed, how many gear wheel are in contact with this gear wheel? How many gear wheel? That means I'm asking, if take a certain position, let's take, how many gear wheels are passing from this certain position? Let's take this position as A. I'm asking, that means when it produces the N2 revolutions, how many teeth are passing A position? How many? T2 N2. T2 N2. That means this number of gear teeth are in contact with the third gear wheel. Okay, third gear wheel also contact with this number of gear teeth. So this third gear wheel has the T3 teeth. So by dividing this T3 we are getting N3. Okay, N3. In here, instead of N2 we are going to put this equation. Okay, this equation, then we are getting N3 is equal this N2, we are going to put this one, T1 T2 into T2 T3 into N1. Okay, then you can see in this equation we can further simplify this equation. N3 is equal T1 divided by T3 into N1. Okay, then in that way this one also we can write N3 divided by N1 is equal T1 divided by T3. You can see very important thing for this speed ratio. Only the starting and end J wheels are there. The intermediate J wheel does not affect to the speed ratio in simple gear trains. Okay, keep remember this one. The intermediate J wheel does not involve into speed ratio of this output and input speed ratio. Okay, if we can use any number of teeth for this intermediate gear, it only doing changing the direction of the rotation. Okay, it may be having the multiple number of intermediate gear. All are does not affected to the speed ratio. Only thing those are affected only for the rotational direction only. Okay, keep remember that one, because this equation does not contain T2 value. Okay, then this is about the simple gear train. Then again, compound gear train also used in lathe operations. Let's take before going to the compound gear train, let's do the example problem from this simple gear train. Okay, before going to the compound gear train, to discuss the compound gear train, try to work out this example problem. Okay, a simple gear train consists of 3 gears, each fixed on the separate shaft as shown in the figure. The gear 1 is the driver and the gear 3 is the driven. The gear is running at first gear. Gear 1 is the gear 1 driver is running at 1000 rpm. The number of teeth on the 1, 2 and 3 are 40, 50 and 80 respectively. Determine the speed ratio of the gear train. Driver or driven, the speed of rotation of the driven wheel and the direction. Okay, then let's see how to do this example. Then here driver, I'll draw the diagram also. Driver, intermediate gear and the driven. Okay, driver having the 40 teeth, then the driven having the 50 teeth, this one having the 80 teeth, T1, T2, T3. This is rotating direction. Let's take this is rotating in a clockwise direction, 1000 rpm. 1000 n1 is equal 1000. This is n2, this is n3. Problem is asking the speed ratio, n1 to n3 ratio is asking, so I will use the basic method for this one. Okay, basic method I'm going to use. Okay, the basic method, I'm asking if this is producing the n1 revolutions, how many teeth are passed in this point? If this is fixed, how many teeth are passing in the circumference? It have the T1 teeth. When it produces the n1 revolutions, T1 n1 teeth pass in this point. That means T1 n1 teeth are in contact with the second gear wheel. Okay, second gear wheel circumference having the T2 teeth. If we divide by this one T2, we are getting n2. Okay, if this is rotating with n2 speed, how many teeth are in contact with the third gear wheel? That is equal to n2 into T2, because its circumference having the T2 teeth and it rotating with it producing the N2 revolutions, then it is contacting N2 T2 teeth with the third J wheel. If this is the third J wheel having the T3 T, what is the speed? N3. Okay, this is the relationship. The previously also we obtained this relationship. So then we can substitute in this here into T1 T2 into T2 T3 into N1 is equal N3. Okay, we can further simplify this one. Okay, this is driver driven. Then speed ratio N3 to N1 is equal speed ratio T1 to T3. T1 to T3. So speed ratio, we can write the equation. The N3 mean driven speed. N1 mean driver speed. Driver speed is equal. What is T1? T1 is given the 40. T3 is given 80. That is equal 1 over 2. Okay, this is the speed ratio. This is the speed ratio. This is the speed ratio. That means when this is the driven, when driver producing the 2 revolutions, driven produce 1 revolutions. When driver producing the 2 revolutions, driven produces 1 revolutions. Okay, that is the ratio. Driven 1, driver 2. That means when driver producing the 2 revolutions, driven produce 1 revolutions. Okay. Then the problem is also asking rotational speed. Okay, rotational speed. Then if driver speed is 1000 and driven is equal, half into 1000, 500 RPM. 500 RPM. Okay, keep remember. Okay. Then let's move to the compound gear train. Second one, compound gear trains. Okay, compound gear train. Actually, these compound gear trains are used to get the larger gear ratios, which cannot obtain, which is difficult to obtain from the simple gear trains. These compound gear trains are used. Okay. Then to get the larger gear ratios, compound gear trains, at least one shaft carries more than 1 G. Okay, at least one shaft carries more than 1 G. So I will draw the diagram for this one. Let's take, this is the driver. Let's take another machine gear wheel, let's take yeah. Then okay. Okay, then here you can see, let's take, this is rotating with n1 speed. Then if this is rotating in this direction, this one rotating in this direction. Okay, this is let's take, produce the n2 revolutions for this gear wheel, because it is mounted on the same gear, same shaft. So for this gear wheel also speed is equal to n2. If this is meshing with this gear wheel, this is rotating in this direction, this is rotating in this direction, that is equal to n3. Okay, let's take this t1 teeth, t2 teeth, t3 teeth, and the t4 teeth. Okay, then if you look from the top, if you look from the top, if you look from the frontal plan view, we are having this kind of view. This is the first gear wheel. Okay, then the second gear wheel in contact, then another gear wheel is connected like this. This is the output shaft, this is the input shaft. Input, output, this is the input, input, this is the output. If you look from the plan view, this is how it look like. You can see this shaft carries the two JVs, that's why it's become compound gear train. This shaft, you can see this shaft is carries the two JVs, that's why it's become compound gear train. This is the output. These are called the compound gear trains. Same way we can find the speed ratio. Use that method. Okay. Then here we are going to find the speed ratio for this gear train. Okay. Okay. Here this is producing the n1 revolutions. Then its circumference having the t1 teeth. How many teeth contacting with this gear wheel? That is equal to t1 n1 teeth contacting with this second gear wheel. If the second gear wheel having the t2 teeth, how many revolutions it produce? T2, sorry, divided by t2 revolutions is produced. That means that is equal to n2. That is equal to n2. Because these two GVs are connected by a single shaft, this n2 speed is also same for this smaller GV also. If this smaller GV is rotating with the n2 speed and it circumference having the t2 t3 teeth, how many teeth contacting with this GV? The fourth GV, n2 into t3 GVs are contacting in this. If this is having the t4 teeth, how many revolutions it produce? N4. Okay. In this equation, I am going to, instead of n2, I am going to put this term. So then what happened? T1 into T2 into T3 divided by T4 into N1 is equal N4. Then you can see the output is P. then you can see the output speed. The speed ratio, if you can use the speed ratio, N4 to N1 is equal T1 divided by T2 into T3 divided by T4. Okay, the speed ratio we are getting the individual the couple teeth ratio multiplying the couple teeth ratio. Here T1 into T2, T3 to T4. If you multiply these ratio, both the ratio, we are getting the speed ratio. Okay, I think you all more clear with this calculation, the compound gear train, the N4 to N1. Okay, then let's do the example problem from this compound gear train, then you will more clear with this one. Okay, try to work out this problem. I think goal. I will read this one. In a compound gear train, the shown in the figure, the power is transmitted from motor shaft running at 1450 rpm in clockwise direction. Clockwise direction to output shaft. The motor shaft is connected to the gear 1. This is the gear 1. Output shaft is connected to the gear 4. This is the gear 4. Determine the speed and direction of the output shaft. Okay, so let's see how to do this example problem from the compound gear train. Example. Okay, example, I will draw the gear assembly also. Then the large gear wheel. And this smaller one. Then next gear wheel. Okay, then this one having the T1 is equal 20, T2 is equal 100, T3 is equal 30, T4 is equal 60. Okay, T4 is equal 60. Then how to solve this problem? Same thing, I'm going to use the basic method of the equations. Okay, then if this is producing the N1 speed, this one produce N2 speed, N2 speed. This one also same, the speed is same because it is connected to the same shaft. So if this is rotating in this direction, this is rotating in this direction. If this is clockwise, this one also clockwise output. If this is anti-clockwise, this one also anti-clockwise. Okay, then in this gear wheel, its circumference having the T1 teeth, then it is rotating with N1 RPM, N1 speed. Then how many teeth it contact with the second gear wheel if it is rotate N1 revolutions? N1 T1 teeth in contact with the second gear wheel. If the second gear wheel having the T2 teeth, how many revolutions is produced? we are getting by dividing T2 is equal to N2. That is common to the small gear wheel also connected to same shaft. Okay. So then if this is having the three teeth, how many gear wheels are contacting with this second gear wheel when it rotating N2 revolutions? N2 into T3. If this is having T4 teeth, we are getting output as N3. Okay, N3. So then by connecting these two equations, T1 into T2 into T3 divided by T4 into N1 is equal N3. Okay, this is the equation finally we are getting. So then we can substitute the values in this equation. The N3 we have to calculate. What is T1? T1 is equal 20. What is T2? 100. T3 30. T4 60. So what is N1? What is N1 is given 1450. So then we are getting the N3. What is N3? We are getting the N3. Here it is 5. Here it is 1 and 2. Here it is 1450 divided by 10. So for the N3 we are getting 145 RPM. Output is the 145 RPM in a clockwise direction. This is the solution for this gear train calculation, compound gear train calculation. Okay, so far we discussed about this simple gear train and the compound gear train, because when designing a gear train to cut a certain pitch value, that means okay, this spindle rotation and the least screw rotation is interconnected using the gear train. The compound gear train and the simple gear train is used. So then knowledge about this calculation, speed calculation in simple gear train and compound gear train is essential when designing this gear train. Okay, then on the next lecture we are going to design this gear train. Then we can discuss how to design this gears and gear compound gear train and simple gear train using the available gears. That means with the lathe machine, the set of gear wheels are coming with the older, especially in older type lathe machine, starting from the 20 teeth up to 120 teeth gear wheels coming in 5-step intervals, 5-step teeth intervals. So then how to select, let's see how to obtain this gear ratio from these available gears on next lecture. Okay, thank you.